Hi there, my name is Andreas Klockner, and I'm looking forward to having you in my tutorial from description to code generation, building high-performance tools in Python. A harsh reality of doing scientific computing with an eye towards high performance is that even if the math idea that you're trying to express not all that terribly complicated, the code that gets those ideas and computations to high performance almost certainly is very complicated. And the struggle then is to try and manage all this incidental complexity. And the obvious idea would be, well, why don't we just try and write code whose complexity is really just commensurate with the math idea that we're trying to express, while obviously we're trying to hold on to all that precious performance that we would win with a grubby code. So this tutorial is about a set of Python tools that are designed to do exactly that. And it all starts with the ability to specify domain-specific languages that will work on and transform, say, you have a PDE operator, you slap some boundary conditions on there, and you discretize it, and ultimately what you want to wind up with is a bunch of code that may, for example, run on a GPU. And to keep this tutorial as entertaining as possible, the way we'll do this is through a sequence of notebooks. So you'll see me demonstrate the tools that I want to show you right there in front of your eyes, and you'll also have the same notebooks in a virtual machine that you can follow along and also try and experiment a little. In addition, we'll have little exercises so that you can practice and pull me aside to ask questions. Just briefly, what will we do? Well, I'll give you a quick overview of Python just so that you can be productive even if you've never written Python before. We'll work on specifying domain-specific languages using tools like expression trees, and towards getting that code that we specify to actually execute using OpenCL, so we'll take a brief look at that. We'll worry about generating code, first by very simple means, such as what I'm demonstrating here, and then by more sophisticated ways. So one tool, for example, is called Loopy, that will help us transform expression trees into high-performance GPU code. And that's about it. And I'm very much looking forward to seeing you at Supercomputing.